Hi and hello everyone, welcome to my channel. So there is a new video and there is a new update from last experimental video. In the last video we discussed about transistors, transistor basic and everything. So in the last video we discussed what is the type of transistor, how the transistor going to construct, and what are the structures available, what are the pins available, everything we discussed. What we are going to discuss today, the transfer resistor, that means transistor, there is a basic common operation of the transistor are there. The common operations are like a common base connection, common base, that is very important, don't forget. Okay, so there is a three set of connections are available. Common base configuration, not connection, that one is called as a configuration, and then common emitter configuration, common collector configuration. That means in this first word common base is a common terminal. Clear? Figure it out, put in the message in the comment box. Common emitter means emitter is a common terminal. Common collector means collector is a common terminal. So based on the application and the priority and performance of the circuit, they are going to select which type of configuration or which type of connection needed for that particular application. Already I told you transistors are very important for switching operation and also for amplification operation. Okay, so here what I am going to discuss, so compare these three techniques. Common emitter configuration only I am going to take today. Remaining things we will discuss in the later on. So common base connections, just you have to look it. So today I am going to take only for common emitter configuration. So already I told you common base is a common. So in the common base, common emitter, common collector, everything is very simple only. Okay, so see here in the circuit arrangement, the input is applied between base and emitter. So input is applied between base and emitter. So input is applied between base and emitter. See here, input is applied between base and emitter. Output is taken from the collector and the emitter. Output is taken from the collector and the emitter. So collector, so this is the transistor structure. Okay, output is taken from collector and the emitter. So like this it will come. Okay, that is called common emitter configuration. So already we know that there is a two type of transistor connections are there. Okay, that means that the connection is called it as NPN transistor and PNP transistor. PNP transistor, that we will discuss in the already in the last class. What is in the NPN, what is in the PNP. From here the common emitter transistor I am going to use in the type of common NPN transistor and also PNP transistor. See here, this is the structure belongs to NPN. This structure belongs to NPN, symbol of the transistor. So this transistor is belongs to PNP, symbol of the transistor. So common emitter is common. Emitter is common between input. This the terminal is called input terminal. This one is output terminal. So here common emitter, the same thing, that is called PNP transistor. PNP means that emitter terminal is going to inside the base. Okay, so this is called input, this is called output terminal. Okay, so we are going to give one signal to the transistor. Okay, through the condition of biasing. Biasing means applying the voltage. It is called biasing. Forward bias and reverse bias, that also we discussed in the last class. Forward bias and reverse biasing. Forward bias means positive is connected to the positive terminal, negative is connected to the negative terminal, that is called forward bias. The reverse bias is you have to take ulta, like a reverse connection. Okay, see here we are going to give based on the given circuit diagram, emitter negative and then positive we are going to connect here. Output we are going to take this area, and then input we are going to give through the signal. Okay, so for demonstration purpose we have to take any one method, no need to take both the method. So in that every configuration we need some important parameters. Parameters are very important. So here what we are going to take base amplification factor like beta, base amplification factor like beta terminal. Beta terminal means the input circuits and output circuits we are going to give. So what we are going to take beta, alpha, gamma. There is a three terminals are available, beta, alpha and gamma. There is a three terminal. Common emitter we are going to use beta terminal, common base we are going to use alpha terminal, common collector we are going to use gamma terminal. Okay, so base current amplification factor. Already I told you transistors are mainly used in the amplification purpose only. Okay, base current amplification factor beta equal to del IC by del IB. IC equal to collector current, deviation of the collector current, change in collector current by change in base current is called base current amplification factor. The term is very important. So what is the relation between beta and alpha? Already I told you, the common base and common collector very important. What is the relation between beta and alpha and gamma, gamma and beta? So we have to learn everything. Okay, usually the beta is generally greater than 20%, 20 value. Usually the value ranges from 20 to 500. The value ranges from 20 to 500. That means the beta value. While we are going to solve the problem, they will give the beta value the time of solving time. So then further the relation between beta and alpha, that is also very important things. See here, alpha equal to, already we know that del IC equal to del IB. So where is alpha? Alpha equal to del IC by del IE. Beta equal to change in collector current by base current. Alpha equal to change in collector current and emitter current. Now everyone knows IE equal to IB plus IC. Base current plus collector current. That means here the collector terminal, emitter terminal, base terminal. So here how it will come? Here this is called IB, this is called IC. So here total IE equal to this current plus this current, it will come this area. IE equal to IB plus IC. So this is called common emitter configuration. So based on that some relations also there. Del IE equal to del IB plus del IC, del IB equal to del IB plus minus del IC. Okay, so what is the value for beta? Beta already we know that beta equal to del IC over change in emitter current, change in collector current. Okay, del IC means change in emitter current, then change in collector current, that is called as del IC. So based on that beta value and also alpha, gamma. Okay, here what we are going to do, we are going to consider only of beta and alpha. What is the relation between beta and alpha? Okay, so based on that del IC, del IE minus del IC over, that is called beta value. So in the beta value what we are going to do, so relation between beta and alpha, that is called as alpha 1 minus alpha. So these formulas are very important while we are going to solve the problem. Okay, how it came? So just we have substitute the del IC by del IE. So in the alpha value del IC equal to del IE. So del IC equal to del IE, you replace this value alpha by alpha. So finally alpha by 1 minus alpha. So finally beta equal to alpha by 1 minus. This is the relation between alpha and beta. Okay, here alpha is approximately unity value. So B approaches as a infinity. So here B equal to infinity, alpha equal to unity value. That value is also very important while considering the common emitter configuration. Then common emitter configuration, beta always the beta value is always 90 to 95. So this parameter also very important. Okay, this is a very basic information about the common emitter configuration. After that, collector current also there, leakage current also there, that we will discuss in the next video. Okay, now I am going to discuss about the common emitter configuration of input and output characteristics. Okay, please wait for next video. We will discuss about the common emitter configuration of input and output. Thank you once again.